Hello, in this knowledge clip I will show you how to do a cross-variable analysis for the sample and for the population in the case where you cross an independent nominal or ordinal variable with another nominal or ordinal dependent variable. So in this case, we will do a certain type of analysis, and I will again use my case of splash fun here, a survey that was taken in an indoor swimming pool where I have some questions. One of the questions was, for example, do you use a sauna, yes or no, where number 1 is yes and number 2 is no. And another question was, what is your gender? Now, in another knowledge clip, I have already shown you how to analyze each of those individual variables, but right now we will do a cross analysis. Therefore, we will use a researched question. This here will be our research question. Is there a difference between the males and the females regarding their use of the sauna? So you see, in this case, we want to see if the sauna use between the males and the females is really different. Now, how do we know how to start with this analysis? Because we have two variables here. We have the gender variable and we have the use of the sauna variable. Now, you know that right now we're in a certain scenario where we're crossing both nominals and ordinals, but you see here that the gender variable is in this case our independent variable, and that independent variable is actually also a nominal variable. So that means that we are creating two categories in our independent variable, namely male and female. And we cross that with sauna use, another variable in our research, and this here is our dependent variable. This dependent variable is also a nominal variable, because I also ask you the question, well, did you use a sauna, yes or no? So again, we have two options there, which again results in a nominal variable. Now, this type of analysis, we can do this for the sample, so sample analysis, and we can also do this for the population. For the sample analysis, well, if you want to know what to do, you can here go to a decision scheme. And in this decision scheme, you will see what type of analysis that there are possible. Now, in this case, we are clearly here in the first box, and in the first box you see that we're crossing nominals or ordinals with each other, and therefore we can do a cross-table analysis for the sample or even a cluster bar chart. There is another knowledge clip about that, and we need to do the chi-square test for the population. Okay, let's see what that means for a sample analysis. So if we do our sample analysis here, we can just insert a pivot table where we go to the data and then include the entire data set here to create my pivot table. So the idea is that I want to do a cross table here. In the cross table, I have my dependent variable in the rows and my independent variable in the columns. So I will put my gender in the columns, and you immediately see that that is number 1 and number 2. Maybe let's label that immediately, because we know that number 1 is a male person, male, and number 2 is a female person. Now, in our rows, we're going to put our dependent variable, and that is our sauna use in this case. So I put my sauna use here in my rows, and again I have a 1 and a 2 here. Looking at the questions of my survey, I know that a 1 is yes, I used the sauna, and number 2 is no, I did not use the sauna. And now we can make a comparison between both the males and the females. Again, we can add the absolute frequency or the count and also the relative frequency. Therefore, we use our dependent variable, which in this case is a sauna use, to drag and drop to the values. Now, Excel always by default calculates the sum, but we will always change that using the value field settings into the count. Now, if we just put the counts, it means that we're just going to count how many males and females use a sauna and do not use a sauna, which is the absolute frequency indicated by a small n. Now, it must be very clear that based on only these values, you can never draw a conclusion, because you would draw the conclusion that more females use a sauna and more females at the same time do also not use a sauna, which is of course a stupid conclusion if you want to see if there is a difference between the males and the females. So it's ridiculous to compare absolute frequencies because our column totals are not the same. Therefore, we will add um, percentages, relative percentages that will sum up to 100% for every column. So therefore, I again drag and drop my dependent variable to my values. I change again using my value field setting the summarized value into count, but now I show the value as a percentage of my column total, and that is my relative frequency. And now you see my small f here indicating my relative frequency. Now you can actually see that percentage wise more males use the sauna compared to females, and more females do not use the sauna compared to the males. So now using these relative frequencies, you can draw a useful conclusion for the sample, meaning that males use it more than females. But again, this is of course just a sample analysis. What about the population analysis? Because the conclusion that we draw from our sample, meaning that the males use it more compared to the females, is of course only valid for those 150 people in my sample. Can I extend that conclusion to my population? Well, therefore we need a statistical test, a population test. And going back to my decision scheme here, you can see that in this case we're going to use that chi-square test to test this for the population. Now, how do we do that? Well, first of all, we're going to see which test that we need. And the test that we need is the chi-square test. So the chi-square test means that we're going to apply this test to test our sample conclusion for the population. In a second step, we always formulate what is called a null hypothesis, which is a starting hypothesis for a statistical test. And a statistical test always assumes equality between the things that you're comparing. Or in other words, that there is no difference between, in this case, the sauna use of the males and females. That is what we call our null hypothesis. That's a starting hypothesis. And then every statistical test is going to look for differences using a measure of difference. So we're going to calculate the measure of difference. And for the chi-square test or chi-square test, that is the chi-square value. And the chi-square value summarizes, in other words, all the differences that you observe in your sample, because you see that those percentages are definitely not the same. There are differences across the males and the females. So we will summarize all those differences calculating that chi-square value. To do that, we will use an online calculator, and going back to my decision scheme here, we can scroll down a little bit, and that will guide us to this online calculator for the social sciences, the chi-square calculator. Let's fill in here the groups. So we have, yes, I used the sauna, no, I did not use the sauna, and we're comparing males versus females. I just fill in my groups and categories here, just checking that indeed we first have male and then female. Now let's go next, and then we have to fill in our observed frequencies, that are our absolute frequencies. So in other words, that's the 24, the 41, the 26 and the 59. Those are the frequencies that we observe here in our sample. So let's fill them in: 24, 41, 26 and 59. So I fill in all my observed frequencies, then I click next, and then you can indicate your significance level, which is in our case always 5%. So I calculate a chi-square value, and then I find here the outputs. So let's maybe quickly put this here in my Excel file as well. So this is the outputs that I need. It takes some time. There it is. And this output shows us the results of that chi-square test, meaning that the resulting value, the summarizing value that summarizes all the difference, the chi-square value, is 0.6652. And now the test is going to see, is that difference actually significant or not? So by calculating that measure of difference, we can in a fourth step check, is that measure of difference statistically significant or not? And therefore we use the p-value. And the p-value in this case, and you can read it here in red, is 0.414745. That is the p-value. Now, in order to know if that summarizing value, that chi-square value, is a lot or not, in order to see if the differences in our sample are significant or not, we're going to compare that p-value to 5%, to a significance level. And again, because in marketing we use a 95% confidence level, we always compare it to 5%. So we can see here now that our p-value is actually, and now pay attention, this is actually 41.47%. You see that this is bigger than 5%. Now what does it mean? It means that we did not find a significant difference between the sauna use of the males and the females. So no significant difference between the sauna use. We observed a difference, that's true. Here in my frequency table on top of my screen, you can still see that we almost had 37% of the males that use the sauna compared to only 13.5% females that use the sauna. So there is a difference there of almost 6 to 7%, but those differences are not significant. So we do not have a significant difference here. We're going to not reject our null hypothesis. And that means that the difference observed in the sample was actually a coincidence. Meaning that, okay, apparently if we went to that swimming pool on a particular day and we questioned 150 people, apparently on that instance or for that day, it was true that the males used the sauna more compared to the females. However, that conclusion is not valid for all our customers. The difference observed in my sample is not significant. It can actually be coincidence. If you would repeat the sample over and over and over again, we will not find that same conclusion in at least 95% of the cases. So we cannot extend our sample conclusion to the population. That difference observed in the sample is insignificant. It's actually not true for all our customers with 95% confidence. And that is how you analyze a rhesus question with nominals or ordinals in both a dependent and independent variable for your sample and for your population.